In our previous video, we calculated gravitational potential energy. We deduced that there was no elastic potential energy because Paddington had fallen the unstretched length of the bungee cord and no more. Therefore, the bungee cord has not stretched and cannot have any elastic potential energy. And we also deduced that the total energy, because energy is conserved, would be the same as initial gravitational potential energy, which was 9.8 joules. Now let's go ahead and calculate kinetic energy. So first of all, when we say generalized equation, what we're saying is an equation that uses nothing but variables. And remember, in physics, we try to make our variables clear by using letters that represent what it is. So for example, E sub g is gravitational potential energy, E sub k is kinetic, E sub elas is elastic potential energy. So the equation for E total a total, remember, is just a sum, which is just addition. So to get total energy, we're going to add up the types of energy. So we would simply take our gravitational potential energy from our table, then we would add our kinetic, and then we would add our elastic. So E total equals E gravitational potential energy plus E kinetic plus E elastic. Okay? So now we're going to go ahead and use this information to calculate our kinetic energy. So our first step is to identify what numbers we know. Again, if we look at the table, I'll bring that back. We know total, elastic, and gravitational. So I'll go ahead and fill that in here. So total, we know it's 9.8. Gravitational is 4.9. Elastic is 0, which leaves us with an unknown for E kinetic. Now I'm just going to write that by just writing the variable. Then we're going to go ahead and put that into the equation. So again, our E total, and remember, no naked numbers, we always include our unit with every number. E gravity, we don't know this, so I'm going to leave that as EK. It's our unknown, and then elastic. Okay? So let's go ahead and rewrite the values out here because we've substituted. 9.8 joules equals 4.9 joules plus EK plus 0 joules. Now let's go ahead and simplify the equation. 9.8 joules equals 4.9 joules plus EK, because 0 joules is nothing. That can go away. Now we're going to solve. So remember, to solve, we have to undo the addition in order to get EK by itself. So to undo addition, we subtract. So let me go ahead and rewrite one more time. 9.8 joules equals 4.9 joules plus EK. Let's go ahead and undo by subtracting 4.9 joules from both sides. That leaves us with 4.9 joules equals E sub k. So our EK is 4.9 joules. So we've done two mathematical operations in this topic so far. We've done multiplication and we've done addition, right? Because we used totals. And then the other thing we also did is we calculated gravitational potential energy. So just to remember, whenever we're doing gravitational potential energy with mass times gravity times height, that's multiplication. Whenever we're doing total, that's addition. And then we undo the addition with subtraction. Our last step is to explain whether energy is conserved in this scenario. So let's go ahead and put in our 4.9 joules into our table. We know that we started with 9.8 joules of energy. We see that our gravitational potential energy has partially transformed into kinetic, and we see that our total remains 9.8 joules. Therefore, energy has not been created or destroyed, and one type of energy has transformed into another type of energy. So when you explain whether energy is conserved, you would explain that total energy stayed the same, demonstrating that energy is not created or destroyed. And then you would say that one type of energy, gravitational potential energy, transformed into kinetic energy.